Hello friends, right now I'm here to give you a demo on how to create a mesh on some random geometry. Okay, uh, right now you might be seeing the GUI of ICM CFD software. The typical process of creating mesh involves importing the CAD model typically from IGS file, but right now we are not going to deal with complex features as it is a time taking process. Right now I'll create the simple geometry, which is a square duct followed by a simple pipe, circular pipe. On that, how to create a structured mesh using multi-block method. So initially I'm trying to create. Don't worry about what are the steps I'm following or not. This is just to give a overall glimpses on how to create a mesh, how the mesh is being created in ICM CFD. I'm just specifying the size of a simple square duct. Yeah. Now a simple square duct of 2 by 2 by 4 size is created. It has created a curves and the surfaces. Okay. So this is the wireframe view, and if I shade it using solid, like it is shaded. Okay. Now we have created a simple square duct. Followed by that, what we are going to do is we are going to create a circular pipe at the back portion. So using some surface creation option, I am choosing the radius of the pipe, circular pipe, and I am fixing the length of the circular pipe using the points. So this seems to be a little bit bigger than what is expected. So I'll just undo the process and reduce the radius. So the next step is creating parts, which is nothing but boundary tags. So for example, this is the way where the flow enters the domain. I'll differentiate it with colors. This is the phase where the flow enters the domain, which we call it as inlet. Suppose the flow exits the domain through this phase, so we call it as outlet, and rest of the portion is wall. But here we'll differentiate using different names. One is pipe wall, and let's say square duct, so duct wall. So now we have different parts generated. One is inlet, through which the flow enters, and outlet, through which the flow exits, and wall. The domain is bounded by, the flow is bounded by the wall, both pipe and the square duct. Now we are done with the geometry. Just before going to the further steps, like which is meshing, I'll just check the connectivity between all the surfaces which are created using build topology option. Okay, I'll just go one step before. Initially the color of these curves, I'll switch off the surfaces for your understanding. So now we are looking at the colors of the curves. It's like pink in color, and it is a single color. So once we run the build topology, which will tell you the connectivity of the surfaces using different colors. So the red color indicates this line, this particular curve is connected to two different surfaces, which is like top and the side one. Okay, different colors indicate different the connectivity of that particular curve with the surfaces. So right now you don't have to worry about this. Okay, we'll go with blocking. I'm choosing, as this is a simple geometry, I'm choosing to go for multi-block structured hexahedral mesh. I can create tetrahedral mesh much easier than hexahedral, but as this is a simple geometry, we'll see how to create multi-block structured hexahedron in this space. So I'll select the entire space and say create a bounding box, which we used to call as block. Okay, and now this is a monoblock, but if you recollect what you saw in the presentation, there are two different methods in creating block structured mesh. One is monoblock and the multi-block. For this geometry, only single block cannot capture the entire shape of the geometry. So we need to split this bigger bounding box. So now more than one block is involved in capturing the shape. So right now I'll switch off the geometry just to show what I have done. So I have splitted this bigger bounding box into two at the location where the shape of the geometry changes from square to circular. Okay, so I don't have to do anything further to capture the shape of the square duct, because the shape of this left side block is already capturing the square duct. Now I need to do something extra to capture the shape of circular pipe. So now what I have done is I have inserted a block inside the bigger block. Okay, so after inserting, initially there were two blocks. There was a bigger block, I split it into two at the location where the shape changes from square to circular. Now to capture the circular pipe, I have inserted one more block inside the bigger blocks. So that inside block, the smaller block, is connected to the outer blocks with four that has splitted the outer box into five. One is the inside one, innermost one, and the other outer and the circumference of it. Now I'm going to delete the unnecessary blocks. Okay, right now the innermost block which we created to capture it captures the circular duct very well. So I'll stop working on the creation of blocks or splitting of the blocks. Now I'll put constraints on the blocks or edges just to guide it to take the shape of the domain or geometry underneath it. If you watch closely, I'll just what I'm doing is I'm just selecting the particular edges and guiding it or applying constraint on those edges not to move other than this particular curve, which is circle. And if you see, I'm applying similar kind of constraints on vertex to the points. What it does is arrests the degree of freedom of that particular vertex to move out of that location. So now I'm done with constraints. The next step is applying number of nodes or number of mesh counts, mesh cell elements on three different directions. One is I, J and K. I is nothing but X, Y, Z directions. So I'll start with Z direction. Let's say particular edge, I selected the particular edge and I gave 31 as number of nodes. And if I show or display the number of cell counts on each and every edge, the edge opposite to that particular edge which I selected also gets the same number of nodes copied. This is the rule or beauty of structured multi-block, because it has to follow the same pattern of mesh elements. So once you have selected a particular edge, for example on this circular pipe, the block created for the circular pipe, I selected one of the edges and changed the number of nodes to 41. All the other parallel edges, not the adjacent edge, but all the parallel or opposite edges gets the same number of nodes. This is a rule of structured multi-block. So I'm done with Z direction, which is the flow direction. Now I'll give number of nodes in X and Y directions. So before exporting the mesh, there is something called pre-mesh, which will let you give an idea of how the mesh will look like. I'll just shade it and switch off the edges. So the number of the square block, which was initially like this, after applying the constraint or guiding these edges to take the shape of curve, see, this arrow mark indicates this particular edge is going to take the shape of the curve. So the square block is made to take the shape of the circular pipe. So this is how a structured mesh is created. Now further step is checking the quality. There is some quality criteria for structured mesh. So now close to 0 is bad elements and close to 1 is a ideal good element. Okay. So now I just want to see the worst elements in the domain. Okay, I can see all the worst elements are coming in the circular pipe. If I want to improve those, I need to understand why these elements are bad. It seems all the corner elements of particular block, or I would say block created for a circular duct, or having a skewness. This is not a perfect cube or a perfect hexahedron. So I need to do something else, which is O grid. Just observe here. See, right now the bad elements are present at the corner, right? So now I want to improve it somehow. So what I'm trying to do is not only improving this, and also I need a boundary layer everywhere in the domain wherever there are walls. Don't worry if you're not able to follow this step. This is just an tool which helps you to improve your mesh skewness near the walls, and also to create a boundary layer. See, now the corner elements are replaced by perpendicular elements. I'll just replot the quality. Now the quality of the current mesh is more than 0.5, which is more than sufficient for the fluent solver or whichever solver is there. So that's it. Okay, just to I'll go back one step behind and just to show you the difference before. Before creating this boundary layer mesh, the skewed elements were there, and near to the wall, the spacing first cell near to the wall, the spacing is differs, like different spacing is there at different portion of the wall. So after creating the boundary layer mesh and assigning some number of nodes on that, this has improved the skewness and also provide us the boundary layer mesh. So this is the process of creating structured multi-block using ICM CFD for a simpler geometry. The concept is similar. You can apply the same concept, create a bigger bounding box, split the bounding box or block wherever the shape of the geometry is changing, and remove the unwanted blocks and keep the block which is closer to the geometry, like what we did for to capture the shape of circular pipe, and assign number of nodes. And before assigning number of nodes, you have to assign constraints, or I would say the association is the term in ICM CFD. So associate particular edges to the curves to take the shape of the geometry. Yeah, and assign the number of nodes and improve the quality of you can check the quality of cells created, and if you feel the quality has to be improved, you can use boundary layer mesh or O grid, which we call in ICM CFD O grid. You can use that option to create a good quality mesh. I guess that's it. Now you can save the mesh and import it, like export it to the solver, whichever solver is required.